All right, so welcome back to our class, Social Statistics Map 23. And I have seen that we have a lot of us who did not submit homework too, and make sure that we're gonna do it at the end of the day so I can put the gray on blackboard. So for those of you who submitted homework one, you're gonna get points for sure. So those are 5 points. If you got it, it's gonna be part of your grade. Again, homework going to be 10%, and make sure that we do not underestimate the things that we have. So I'm going to share my screen, and hopefully that you guys can see them. Okay, so again, that I changed the assignment submission a little bit. So you have to go on homework, and then you click on the header. So this is where you're going to get homework 1, 2, 3, and so on and so forth. All right. There will be a quiz coming up after, so that will be on
Can
this
you do that again,
Wednesday.
please?
All right. So you click on the header, right? The homework. You click on this, and then you're gonna see all the homework 1, 2, and 3. So if you want to submit
What about
homework one,
setting? You click.
and then you just click on homework one and to submit it. If you want to have homework two, and make sure that you're gonna click on homework two, and then you can submit it. Homework three will be due next Tuesday. Sorry, next Monday. I apologize. So I make sure that you're gonna get it done as soon as possible. So the deadline is next Monday, but you can finish it and submit it this Wednesday if you want to. So that is not a big deal. But the most important thing is that I need you guys to submit the homework correctly on Blackboard. For those of you who do not have your homework submitted, make sure that you do. I'm gonna send an email to remind you about the homework. I think I did, but I'm not sure. If all of you actually received the message. And remember that the homework it has to be under the assessment. So again, let me just do that again. Just want to make sure that everybody actually got it. So since there are more file, I'm going to put on homework one and in the homework folder, and we can check all of them, 1, 2, and 3. Okay, so all of that going to be part of your grade. If you don't submit it, it's going to be really, really hard to get a good grade in this class. Um, yes, you can resubmit it, but once I got a check, once you got 5 points, then meaning that your submission is correct. Okay, so if you don't get the full credit for that, meaning that you are having a certain things. Okay. Um, so I'm gonna mute a little bit. Just want to make sure that I don't hear some echo and so on and so forth. Okay. So we're gonna start. We're gonna continue on chapter 3. How many of you read the file? So literally, we have the file right there. So this is chapter 3 summary, and make sure that you're gonna download it. Right there, you click on it, and for the practice problem, make sure that you're not gonna do all of these problems because there will be too much to do on this uh, type of practice question.
You sound low.
Yeah, actually, I have to put down the headphone a little bit, but is it is it audible? Okay, so generally, what we'll be working on for today is literally we have to be continue on chapter 3. So that will be the mean and standard deviations, and after that we have to move on to the final summary. So there there will be a certain thing that is skip. Let's say we're gonna skip some stuff. Um, the reason behind that because we don't have time to cover every single chapter. Okay, so whatever that I cover will be on the exams. So make sure that we're not going to forget it or live it. You have to practice, and if you have any questions, don't hesitate to let me know that you'll be on the office hour for today on Monday after class. So that'll be from 3:30 up to 4:30 p.m. So um, you can be on the Zoom and on these hours and ask me any question that you have. So that's really important. Okay. So Well, we'll be in chapter 3. Let me just remind you that we're going to cover a few things. So we are heading to the mean standard deviation. That will be the topic that we're going to spend time working on. Okay, so that's important. So what will be on this chapter is that we need to know how to compute the mean and the standard deviation. So in this case, so that's really important. We need to know how to compute them. Okay, so let me just remind you, we're gonna do like some practice questions how I'm gonna compute that. I give you one example and see how how the data is spread around a mean. And the bigger the spread, the bigger the standard deviation. So we're going to look at a certain chapter. No, I'm sorry, not homework. A certain chapter. Let's say we're gonna go to practice problem for chapter 3. Assuming that we have like a bunch of data set. Let's say we have question number 4, right? And then we want to compute a mean and sample standard deviation. We're going to do the final summary later on after we finish that. So we're going to do these questions and see how it goes. Okay. So we have like a 6 data set, and let's see how it's going to be. Okay, so I'm going to copy and paste the questions. All right, so this is a thing that I have. Right, so let me just copy this and paste this question. Okay. All right, so this is what the question looks like. So since the question gives us 6 data, so we're going to put down 6, right? And equal to 6. So that's important that we write down the number of data sets correctly. So we're going to count them 1, 2, 3, 4, 5, 6. So this is the average. This is the number of data set. We can see through it by the question as well. We have 6 top energy drinks, and it gives us a certain caffeine for each type of the energy drink that we have, and see how it's going to matter. So when we compute the average, we just call the mean, and again that we're going to use a simple, let's say X bar. So that's important that we use the correct symbol for that. So if you don't want to write them down the mean of X bar, that's fine, just leave it alone. It's not going to affect us at all. So so after that, we're gonna add of all these values, right? So we're gonna take 12 plus 17, 17 plus 9 plus 11 plus 15 and 8, all right? So we have 6 number, and then we divide it by the number of data set. So apparently that we have 6 data, and then we have to divide it by 6. So that's important. Okay, so we divide it by 6. Let's see. How we're gonna do these calculations? Of course, we're not gonna do it on like by hand or something, right? So we have to do it on calculator. So it's always good that we're gonna use a calculator to do with that. So we're gonna use like TI-83. I feel like it is a really good calculator because it never run out of battery, and you can use it anytime you want to. Correct? So in this case, that we're going to take 12 plus 17 plus 9 plus 11 plus 15 and 8, right? So we're going to add them up like 6 different data sets. So the sum has to be equal to 73. So we need to add them up first, and then we hit enter. We got 73 before we divide it by 6. Okay, so we divided by 6. Later on, we got the answers, which is equal to 12. So in this case, that we're going
You mean 72, not 73?
Yeah, 72, I think. Yeah,
I have a question.
Yep.
When it says compute the mean, that's the step we're doing right now, right?
Yeah, so that's the
The
average.
first step. All right.
So in order to compute a mean, we just add up all the data sets, and then we divide it by number of data set. So let's say I give you 5 data set, we add up all the values, and then we divide it by 5. So this is how we're going to compute the average. So after we take the sum, and then we divide it by 6, and the answer to that will be equal to 12, correct? So let me just remind you that we need to add them up first, and then you have to hit enter before we divide. If we do something like that on the exam, you're gonna get it wrong. Let me show you what it is. All right, if I do something like that, if I don't hit equal after I add 8, I'm gonna get different answers from 12. So I'm gonna get 65 something. That is wrong, right? The average for all of these numbers, see that the biggest value that we have is 17. How is that possible? The average, which neutralize all the data set, will equal to 65. That doesn't make any mathematical sense. So in other words, when you add them up, it's always important that we're going to hit equal, right? And then we're going to hit equal. And after that, we're going to divide it by 6. Okay, we divide it by 6, which is the number of days. Okay, so that's important. All right, so after we get the 12, and then we're going to make a chart. So the chart, again, that has 4 columns, and then we only do the math for the last 2 columns. So the first column will be called the data. So the data will be something that we put them down. So the data set we have in this case will be 12, and then 17, and then 9, and then 11, and then 15, and then 8. So after that, we're going to go to the next part.
So when it says compute sample standard deviation,
yeah,
we
so
do better.
that is a sample standard. The sample meaning that it's coming from a sample data, which is compute a standard deviation from the given sample. Yeah, so this will be the step how we're going to compute the sample standard deviation. So the next step that we're going to write down the average, or in other words, we put down a mean. So which number should we put them down on the second column?
12.
12.
Exactly, because this is something that we computed. So we're going to put 12 into the second column. So we have to go here, not 6, okay? You just have to go right there. So just indicate them by arrow and use different marker for that. So in this case, we have 12, and then we're going to put them down 12, 12, and 12 for all of that. Okay, so I'm going to put this 12, and then 12. I mean, the first 2 columns we don't do any calculation for that. We just want to see how these data set going to spread out compared to number 12, right? Compared to the average, which is 12 that we just computed. And since we have 6 data, we're going to put down 12 for 6 of them, 1, 2, 3, 4, 5, 6, right? So the next step, we're going to take it different. We measure the spread, the so-called deviation, okay? So some of you might put down a different, some of you might put down a deviation. That's perfectly okay. For me, they are the same thing. The deviation, we want to measure the change. So just want to make sure that we are understand what we're doing is we're taking a subtract, right? We need to take the data, subtract the mean. In this case, we have 12 minus 12. So we get the answers, which is equal to 0, correct? And then we keep doing that until we finish the last column, the last row. So we have 17 minus 12, and apparently the answers give us is 5. And then 9 minus 12. And again, if we unsure what we're doing, don't hesitate to use a calculator. Remember, we never run out of battery, so why don't we use this calculator? We take 17 minus 12, we got 5, and 9 minus 12, we got -3. And then we keep doing that until we finish the list. And 11 minus 12, and we got -1, right? And then we keep doing that. So the fifth row, we have 15 minus 12, and we got the answers as -3. And finally, we have 8 minus 12, and then the answer that we got is -4. Okay, so this is the thing that we need to compute on a calculator. So after, yeah.
-15 minus 12 is just 3.
I'm sorry?
You put
15
15
I'm
minus 12.
sorry. I apologize. For some reason, I don't know why. Okay, so after that, we're going to do the square. Okay, so the square meaning that we're going to square all the different, because if we add them up, we're going to get 0. Okay, because the mean means that it's neutralize all the data set values. So when we take 0 plus 5 minus 3 minus 1, we add them up, right? And then we're going to get 0 for sure. I'm going to get 0 for sure. So in this case, we don't want the spread to be canceled out, right? So how can we not getting the spread canceled out? So we're going to square each of the difference that we have, right? So in this case, that we have to use the square on a calculator, which is this simple, which is this You have to use that. So we have 0 square again that we're going to have this guy is 0 because 0 times 0 is 0, and we also have 5 square, right? 5 square that we have on this row, on a second row. So 5 square, you're gonna hit on a calculator, you're gonna hit 5, and then you're gonna hit x squared, right? And then we got 25. For those of you who do not want to do 5 square, what is the best option? If I don't want to do the square, for instance, I can't just take 5 times 5. I feel like it's going to be the same thing. 5 times 5, which is 5 squared. Okay. You gotta be really careful when you have to deal with negative term, because we don't want the difference to be canceled out. We want to take all of that into account to measure the spread of the data. So the best strategy when you do the square is to ignore the negative term. Okay, so instead of doing negative 3 square, I just put 3 square. So the answers for that is 9. All right, so very likely the similarly that we're going to have, instead of 1 square, negative 1 square, just take 1 square, and the answers for that is 1. And then 3 square, so the answers for that is 3 times 3, which is 9. Okay, should we do it by hand? The answer is no, because we have a calculator, right? All we have to double check the answers to make sure that it is correct, right? So 5 squared, 25, so all of that is perfectly okay. And then finally, we have 4 times 4 is 16, so this will be the final row that we take into account, right? So we can also take 4 squared in this case. But if you don't want to do 4 squared, you can take 4 times 4. You multiply by itself, meaning that you square it. Okay, so what's going on for this? The total that we have, so total in this case would be the sum. Okay, so the sum of all of these data, of all of these square. So I call this as a total. So we need to compute a total for that. Again, that the total will be the sum of all of that. So that'll be 0 plus 25 plus 9 plus 1 plus 9 plus 16. And then the total for that will be equal to 60. Are we good? So we add up all of these square different. Right, you're going to add up the last column. Remember, we do not add up from the third column. We add up the last column, right? So we need to. So I just want to make sure that we are doing it right. We're going to add up the value from the last column, right? Add up the x squared from the last column. So so that's important. We add them up correctly, and so the x squared for that, this deviation square. So after we add them up, we got the total will be equal to 60, correct? So in this case, so that's really important. When we do the average, we have to divide it by 6 because there are 6 data
I
sets.
have a question.
Yeah.
Why is it not negative 1 squared?
Again, because when you square a negative value, so that become positive.
Okay.
So if we do something like that, so this is the correct way of doing it because we want to square the whole thing, the negative side as well. But if you do something like, I'm sorry, negative 1 square, the same thing as that. But if we do something like that, that will be wrong because when you take the negative side out, so the answer for that in this case will be negative 1. Remember, the last column, I need to go into that. The last column have to be positive, right? I put right there. I'm going to change the marker. Just want to make sure that we are following through. So the last column have to be positive. All of these different have to be positive. When you see a negative value, so that have to be the wrong answers. Okay, so we need to add up all the square from the last column, but what number should we divide? So when you have n equal to 6, then we have to divide by 6 when we compute the average. However, when we want to look for the standard deviation, in this case, we have n equal to 6, but n minus 1 will be equal to 5, right? We take away 1 from that. So instead of we have to divide it by 6, then in this case, we have to divide it by 5.
Wait.
Yeah.
You say that again, please? Could
Yeah,
you say that
rewind.
again?
All right. So what I'm saying is that when we compute the average, we have 6 data set, right? You just add them up and then you divide it by 6. But since the standard deviation from a sample somewhat smaller compared to the population standard deviation because of the fact that the population would be the entire jungle that include all the data set values. So the standard deviation. Yeah, so we have to take
So
away
you
one.
always take one off?
You
Always?
always take one off only when we divide it until the last step. We still have to divide it by 6 when we compute the average. But
Yeah,
we
just at the last step you take
just
one
the
off.
last step before the last step. So always take away 1 when you compute the sample standard deviations. So I put it right here. Are we good? So if I give you 7 data set, then for the last step, then you have to divide by 6. If I give you 10 data set compared to almost the last step, then we have to divide it by 9. Right? If I give you 10, you have to divide by 9. If I give you 11, you have to divide by 10. Usually, I give you around 5, 6, and 7 data sets. 7 will be the most data set that I get, because I don't want you guys like to spend most of your time like writing down how many rows that we have to take into account. Okay, so it shouldn't be that many steps. So we have to take 60, and then we divide it by 5 instead of 6. All right, and then we got the answer. So this fractions going to give us the answers, which is equal to 60 over 5. You got the answer, which is 12. All right, so after we get 12, so 60 over 5, we got 12. After we get 12, so this is not a final answer because we need to because we squared the difference. After the square difference, we need to neutralize the difference. We need to take the square root. So the standard deviations represented by STD. Okay, if you don't want to put that STD, that's fine. You can just put them down as S, or you can write them down as the standard deviation. But usually, I put them down as STD. So the STD will be equal to what? The STD will be equal to the square root of 12. So the square root of the value that we just computed right there.
It'd be 144.
Radical 12 is not 144. 12 is 1 2. So how can we take the square root on a calculator? How can we do the square root on a calculator? So we have to hit what? We have to hit the second and then x squared. Okay, so very important. We have to hit second first and then x squared in order to get the square root correctly. All right, so let me just do it in a calculator and show it to you what it is. Hit second and then x squared. So what we're doing right there, we hit second, right? So it meaning that the calculator performing like the top function. So the top function that we have for the x squared will be the square root. Everybody see the square root right there above x squared. So this is the thing that we're going to take the square root. Yeah, so I completely understand that. Usually, after the outbreak of March, Verizon, AT&T, and the other services provide free internet connection, but now they cancel it out right after the outbreak. So yeah, I got you. Okay. All right. So the final answers that we got when you do the square root of 12, and it will be equal to 3.46. Okay. Are we good? So again, how can we do the square root? We're going to hit second and then x squared, right? So we can see that the square root side, and then you put down 12. So the answer for that will be equal to 3.46.
I got something else.
What do you get?
I got 2 square root 3.
Yeah, so because you're using different calculator, so what you have to be doing will be the following things. Okay, so what calculator that you have?
I have the TI-36X Pro.
The X Pro, correct?
Yes.
And I'm going to show you the image. Does it look like this? Does it look like that?
Yes.
Okay, so I'm going to copy this picture and I'm going to show you how to do these calculators. This calculation, are we good?
Yes.
Okay, so first of all, I'm going to copy this image. This is your entire calculator. Okay, but if I don't have enough time, I want to show you later. So first step that we um, need to I think I need some of this. I miss this, but anyhow. So first step, you're gonna hit second, correct?
Yeah.
You're gonna hit second, right?
Yeah.
And then after that, we're going to hit uh, this guy x squared, correct?
Perfect.
And then you put the 1,
Mm-hmm.
2,
Mm-hmm.
correct? And then you hit this guy, enter, correct?
Got it.
Got it. But it turns out to be 2 radical 3,
Yes.
right? And if you got TI-84, it's even better. Then you're gonna hit one burn above it, so you're gonna hit the approximation.
Yes.
One burn
Okay. It gave me
above
the answer.
that. It should give you the answer, which is 3.46.
Thank
Am I
you.
good? Are we good?
Yes.
So make sure if you don't know how to do it, you're gonna screenshot that, and then so we're gonna hit second x square, and then put 1 2, and hit hand, and then you hit enter, and then after that you're gonna hit the burn above that. So it's indicating the approximation. You see the side, this side, right? This
Yeah.
side meaning approximation for a certain square root or a certain functions, whatever it is, so they can get the binary answers correctly.
Thank you.
You're very welcome. Are we good? So we're gonna do another example. Let's do question. Which question should I do? Can we do question number 3? Ignore final number summary because we're gonna learn it after this. Okay. And again, that we can screenshot that. So we're gonna do question number 3 on a list. I give you a bunch of data set, maybe 5 of them. Okay. And then I want to compute the sample standard deviation. Okay, we ignore the final number summary. The reason behind that because we haven't learned how to do it. Okay, but we learn after today, hopefully. We ignore this. Okay, I mean we did not. I mean this question might be on the exam. The final number summary have to be on the exam, but not today probably. We're gonna learn it later on. Is on homework 3. Yeah, we're gonna learn it. So give me some time for the question until I move very slowly, making sure that we are on the right track. So the first step that we're going to compute the mean and the standard deviation. Ignore the median. We're gonna learn the median later on. So how can we do the mean? So the mean is x bar. So we're gonna add up all of these 5-digit values, right? So we have 2 plus 15 plus 25 plus 17 plus 8. Okay, so that is the thing that we need to add them up. And then we divide it by how many data set that we have right there from that example. So we're going to count them 1, 2, 3, 4, 5. So we need to put them down and equal to 5 first. So that's important. I always use a small n because the sample is the only way that we know how many data set values. If we have a population, there's no way that we use it. So we always use the small n to represent a number of data set from a sample. So in this case, what that we have to divide it by 5 because we have 5 single data set, right? So this have to go into this. Okay, so that's apparently a thing that we're going to be working on, right? So we divide it by 5. Again, that we're going to do it on a calculator. Apparently, when you do the add them up. So we're gonna take 2. We're going to take 2 plus 15 plus 25 plus
67.
17 plus 8, and we got the answers, which is equal to 67. Are we good? So
Yes.
this will be 67, and then we divide it by
5.
5, since we have 5 data sets. So we divide it by 5.
13.4.
Yeah, we do not round them up. Remember that we have to keep a decimal number. For the mean and standard deviation, we make sure that we do not round. So the answer for that is we're going to take 67 over 5. And the answer for that is 13.4. We have to keep 13.4. Do not round down to 13 or round up to 14. Because out of that, you're going to get the wrong answers when we're computing this the standard deviation. All right, so now for the next column that we're going to be working on, we're going to make a chart. The first 2 columns, just the data and the average. So we do not really have to worry about that. And the average that we have to put X bar, if you ask me why we put X bar on top of it, I don't really have the real answer for you because I was born late. So when I learned statistics, it was there and people just use that. And so that's the reason why I don't know why people put the average as the X bar, but why not the add simple? I have no answer for you. Okay, so we just need to accept a lot of syntax in this case. So the data that we have will be 5 of them, right? Because we have 5 single data set. So we have 2, and we have 15, and we have 25, and we have 17. Okay, it doesn't necessarily have to be in order for me computer standard deviation. And after that, we're going to put down the X bar on the second column. So that's important. So the X bar, we call the means or the average. For those of you who love to use average, that's perfectly okay. I do not have any obligation for you guys. Like you have to follow this or you have to follow that. Okay, so this is really up to you. So the mean that we have, that we computed earlier is 13.4. So this guy have to go here. Right, have to go here. So we have to put down 13.4. 13.4. I'm going to change the marker to black and see. Okay, so it looked like that. And then the second row, we're going to get 13.4. And then this guy is 13.4. And then we keep doing them until finish the list. And the next step, again, that we're going to compute a difference, we call it deviation. If you put down different, the same thing. I don't take waypoint, remember, for this step. Okay, I do not take waypoint. So this one I put down the different or deviation. The deviation is a more technical term that we usually hear or we use instead of the different. But if you don't mind doing that, it's perfectly okay. So we're going to take 2 minus 13.4 to get the answers. 13.4, and then we're going to do it on the calculator. Okay. 2 minus 13.4. Make sure that we're not going to do it by hand because other than that, you might make a mistakes on it. So we always good to put that on a calculator. So we got the answer, which is negative 11.4. So that will be the first thing that we need to do, right? So we're going to get negative 11.4. I think I'm running out of space. Okay, let me just draw it a lot better. I think I have to draw it a lot better. So I apologize for that. I don't have enough space for this for this setup. So I'm gonna draw a different line, which is right there. So I need more space for this calculation. Usually I don't have to write them down like 2 minus 13.4, but since we're relatively new to the standard deviations and I don't want you guys to make any mistakes on it, so that's the reason why I put them down. On the exam, we just put as, you just put them down as negative 11.4. I give you full point for that, right? You don't have to write like 2 minus 13.4. You got the answers. Exactly. Yes, the final summary is somewhat fighting 3 minutes. I'm going to show you how to do that later on. The hardest part for this chapter is computing the standard deviations because it's just a lot of work. So again, when we do 15 minus 13.4, again, that you don't have to write them down, like 15 minus 13.4. But again, that the reason why I'm doing it because I want to make sure that you guys are able to see through what we're doing, and we're gonna get this guy is 1.6, and then we also have 25 minus 13.4, and apparently that is going to give us a positive value for this kind of example. We got 11.6. Okay, 11.6. So we're gonna finish that. I'm gonna do all of this. So 17 minus 11, 13.4. So we're gonna do it. So the answer for that, I would say 17 minus 13.4. So the answer is 3.6. Okay. Finally, that we have 8 minus 13.4. So so the answer for that will be negative 5.4. All right. So after that, we're going to compute the compute the compute a square, right? So I put them there at the square deviation. So we put x square. It just put that a square, understand what it is, and then we take 11.4 square, and the answer that we have is 129.96. But remember, since we have a decimal number, we gotta be really careful when we write them down the answers correctly. So 129.96. So that will be the first line, the first row. And then we do the same thing for 1.6 square, we got 2.56. Okay, and then after that, we're going to have to do 11.6 square. We should get around 134.56. And next, we're going to take 3.6 square. The answer for that is 12.96. And finally, what we have is 5.4 square. And the answer for that is 29.16. Okay. So all of that going to give us the square deviation. So we do not cancel out the spread, right? So we're going to take that into account. So by taking the total for all of this, okay? So the total can be computed by doing the summations for all of that. So 129.96 plus 2.56 plus 134.56 plus 12.96. Please try to do these calculations on a calculator and see whether or not you're going to get the same answer. So that'll be 309.2. Okay, so very important. I'm going to put them down 309.2. So that would be the sum, right? So that is the total for all of that. But which number should we divide?
12.4.
We have to divide it by,
Don't you take away 1 from the end?
12.4.
yeah, not
Well,
we do not take away 1 from the mean, we take away 1 from the number of data sets.
so 4.
That would be 4. Very good. But it's really important that I just want to remind you that a number of us from my past semester actually took 13.4 minus 1, but we do not divide it by that big number. After we compute a mean right there, we leave it alone. So first, we need to take away 1 from the number of data sets. So I'm going to change the marker a little bit. So that'll be n minus 1 will be equal to 4, right? So 5 minus 1 is 4. Because it gives you 5 data set. When you compute a mean, you divide it by 5. But when we're computing the standard deviations, we no longer divide it by 5. We divide it by 4, okay? So this is very important because we have 4 data set right there, okay? It has to be the whole number. Yeah, I will excuse you for that version. Yeah, so I completely understand for that. And then we divide it by 4, and the answer for that is 77.3. So this will be pretty much a thing that we put in there, 77.3. I want to change back to the black marker. Just want to make sure that we are, we are working it out correctly. So this is 77.3. And after that, we need to take the square root for that. So the square root, so that we can call the standard deviation. So I use STD to represent the standard deviations, and it will be the square root of 77.3. So that will be the final answers. Okay, again, how can we do the
I
square?
have a question.
Yeah.
So
Yeah. Questions? Hello. Okay. So after we have radicand. Okay. After we have the radicands, we're gonna take radical. We hit second, and then x square, and then put down 77.3. And of course, you're gonna get you never get something with a radicand. You're gonna get the whole number. So the answer for that is 8.79. So that will be the final answers. Okay, 8.79. Just want to remind you that we hit second for that. I just want to write down a step how we're going to do it. So we're going to hit second and plus x squared, and then we're going to insert the values. Okay, so this is the way that we do it. The STD stand for the standard deviation. Just want to make sure that we understand what the syntax looks like. Some of you might be, just don't give me OMG on the exam, okay? Sample standard deviation. So just don't give me like some term that doesn't make any sense, like IDK, right? Don't give me IDK on it, just STD. That'll be 3-letter word that we allow you to use for this type of question. So this is how we compute the sample standard deviation. Are we good? You need one more example? Are we good to go? So you just compute the average,
One more, please.
and then by add them up divided by n, and then write down the data mean, and then after that we take the difference, we square the difference, we take the total, we divide it by n minus 1, and then we do the square root. Okay, those are the steps that we need to follow. So since we want to do one more example.
So it's 5 steps to this, right?
It's actually 5 steps, yeah. It's
5 steps, okay.
First step, we compute the average. Second step, we take the average, subtract from the data, right? We call it difference. So we take data, subtract the average, so that would be second step. The third step, we square each of those. The fourth step, we add them up and divide it by n minus 1. And the fifth step, we take the square root. Right? We can say this is like a 5-step formula, okay? 5-step standard deviation. Are we good? We're gonna do last example and see how it go. Okay. So this is the questions that we have. I think we did this question, did we? I think we just did it. I don't know why I put question number 4. Let's do question number 2 and see what it is. Are we good? Ignore, we just want you to copy the data set. The data, the reason why I'm not going to copy the question because it's giving us like first quartile, it's something that we call the standard deviation. So I'm going to put in there as compute the mean and standard deviation. Standard deviation of the following sample data. Remember, it has to be the sample. Following sample data set. Okay, so what I have in mind is this guy. All right, so we have how many data set that we have right here? So 1, 2, 3, 4, 5, 6, 7. There's 7 of them. I call this as n equal to 7. Okay, and n minus 1 equal to 6. Why we have to do that? Because we're going to use this to divide when we compute the standard deviation. So when we do the average, we cause mean, which is x bar, would be equal to will be equal to the sum, right? The sum for all of that over 7. So we take 10 plus 9 plus 12 plus 8 plus 15 plus 9 plus 7, and we add them up. We divide it by the number of data set. So we need to count them before we divide. So there are 7 of them. So we have to divide 1, 2, 3, 4, 5, 6, 7. So we have to divide it by 7. Okay, so when you do that on a calculator, it turns out to be 10 plus 9 plus 12 plus 8 plus 15 plus 9 plus 7, and then we divide it by 7. We got 70 over 7, so the answer for that equals to 10, right? So we got 70 over 7. Okay. And then the answer for that is 10. All right, so after that, we're going to do the chart. We're going to do the chart. And the first row, the first column will be just writing down a data set. There's no big deal. So I'm going to put them there as 10, 10, and then 9, and then 12, and then 8, 15, I'm sorry, 9, and 7. So this is the thing that we're going to put them down. The second step, we're going to put down the average, right? So we just call it a mean. And now we're going to sketch the column. Okay, so the mean that we have in this case would be 10, 10, 10, 10, 10, 10, and 10. Okay, and after that, we're going to do the different. We call deviations. For those of you who put out different deviations in the exam, but the deviation is more technical term that we use. And then we're going to take the, so 10 minus 10, we're going to get 0. Now I'm a little lazy for that, right? So I'm not going to do the 10 minus 10. So we need to know what it is. So that'd be 0. And 9 minus 10, I got -1, correct? And then we keep doing that. And then 12 minus 10. So 12 minus 10, I got 2. Okay, I got 2. So I'm going to put 2 right here. And 8 minus 10, I got -2. Right? So -2. And 15 minus 10, I got 5. 9 minus 10, I got -1. And this is -3. So finally, we're going to, I'm sorry, now finally, the next step, we're going to square them. So this square, we call x squared. Okay. And then we just square each of these values. So 0 squared is 0. Just want to make sure that we do not take the square root, right? Take the square. And then -1 squared is 1, 2 squared is 4, and then we keep doing that. Okay, and then -2 squared is 4, 5 squared is 25, 1 squared is 1, and 3 squared is 9. And I'm going to count them. So there's 7 of them, 1, 2, 3, 4, 5, 6, 7. So when we do the square, we also have 7 numbers, 1, 2, 3, 4, 5, 6, 7. And all of these numbers has to be positive. And because of that, so this have to be greater than 0. In other words, have to be positive on this side, right? We cannot give me negative values on the last column. Remember that all of this has to be positive. So after that, we're going to do the total. So this will be the next step that we need to do. So a total, we need to add them up. So we add up 0 plus 1 plus 4 plus 4 plus 25 plus 1 plus 9. So the answer in this case will be equal to 44. Okay, so that would be 44. So it will be the total. And then we divide it by what? So we gotta be really careful, right? We can't
6.
by 6. Very good, because I give you 7 data set, right? So we do the average, we divide it by 7. But when we do the deviations, then we have to divide it by 6 right there. Very, very important.
So we're going to do 44 over 6, and the answer for that will be 7.33. So I'm going to put them down, and this will be 7.33. Finally, that we're going to do the STD. The STD will be called a standard deviation. So that would be the square root of 7.33. And the answer for that, I believe, will be on a calculator, right? So we're going to take radical 7.33. We're going to hit second, and then x squared, and then put that 7.33. So the answers that we can see on the screen will be 2.707. So I can round up to 2.71 or 2.7. So that's perfectly okay. Okay, any questions? All right. So if there's no more questions, now we're going to move on to the next part of it. Okay. So the next part of that will be called the final summary. The final summary is somewhat not quite easy for us, but it's in terms of calculations, so that was okay. So now we're going to go to chapter 3, final summary. Okay. I want to put right there, final summary. In this case, just find 3 median. It's as simple as that. So find 3 median. Okay, so that's going to be something that we head into for this Chapter. Chapter. All right. So what it means by that, I wanna box it. And okay, and this a little bit doesn't look like that. But anyhow, so what are we trying to do in this case is to literally understand what a median looks like. So the median is different from what we learned from the average. So the median, also the central tendency, right? So we learned it from last class, was the mean is also a central tendency, but it's neutralizing, I'm sorry about that. It's neutralizing all, instead of all the values, in this case, neutralize the uh, the percentile of a data set. It's different percentile of the data. It's not like um, the it's not like the value. So when you compute the average, then need to add up all the data set values, and then we divide it by the number of data set. But the median is different. The percentile meaning what? Percentile meaning that so each data set will occupy a certain percentile. Okay, would be so a data set will be divided by 100%, but not in terms of the data set value would be divided by 100 percentile. Okay, but in this case, percentile is not about the value, but in this case, it would be the precision of a data set. So that's important. Okay, so we don't really take into account the weight or the value, so we take into account the precision. So that's important. So I'm going to give like a few examples and see how it is. So for instance, I'm going to give you, let's say, 5 data set, 1, 7, 11, 20, and 40. So we can basically see that the median, basically the middle data set value. So this will be, I'm going to point out. So that will be the middle data set value, we call it median. Okay, median here. Data set. Okay, data set. All right. So that's important. Um, um, for for this part, and then we need to figure out what is the middle data set that we have here. So we have 5 different numbers. So it's already in order, and so we can literally check that the middle data set here will be equal to 11. So this will be called a median. Okay, this will be called a median. Okay, so the median will be equal to 11. Okay, so I want to give you another example that's pretty much the same example that we had earlier. So let's say we take 1, 7, 11, and 20, and instead of giving you 40, I give you 100. So I literally change the last data set values, right? I'm going to change that to this, but the median still being changed. So we can literally check that the median still be equal to 11. Okay, so if it changes a certain data set, it doesn't really change the median at all because we only take into account a precision of data sets. So that's really important that we understand the median that way, right? So we have 5 data set. We have the value 1, 7, 11, 20, 40. I got the median will be equal to 11. But if I change from 40 to 100, I still get the same answers, which is also equal to 11. So that's important that we understand. Okay, so usually the median that do not take care about each data's values. You can see that the range for the data set are not going to be matter. So the difference between 1 and 7 will be 6, from 20 to 100 will be 80. So if we have like a sample percentile, but they have different range and different values. So that's normal when we look at the median. Okay, so next step that we're going to be understand what it means by the final summary. So the final summary is somewhat really, really important when we want to look at the data set. Let's say the first quarter, how the US economy doing on the first quarter? So that would be the first 25 percentile, basically 3 months. So this is what we have for the final summary, and that's important. It's different from what we have learned earlier. So the final summary, in this case, that we need to divide a data set into 100%. So this is the thing that we need to be careful. The first 2 number that we're going to get in this case will be equal to the smallest and the largest. So we got 2 numbers. Okay, so the first data set will be the smallest and the largest. So that will be the first 2 numbers. If you pointed out like the smallest data set and the largest data set, you're going to get some point, because find number meaning that we're going to look for the smallest and the largest and the 3 medians. Okay, so the median of the entire data set, I call this guy is Q2. So that will be the median of the entire data set. Okay, so I call this guy Q2. So we have to look for Q2 first. What is happening? What the Q2 doing for the entire data? So we can literally see that it splits up how many data in this case. So it splits up from 1 to 7 on the left side and from 20 and 40 on the right side. So it's going to occupy 50 and 50 percentile. The 50 on the left side and the 50 on the right side. So this will be 50 percentile, and that will also be 50 percentile. So this is really important. So after that, we're going to look at the Q1.
Boy, can you please say that again? Go ahead.
Again, so the median going to split into 50 and 50 percentile. The first 50 and then the last 50 percentile, from the smallest up to the middle data set, and from the middle data set up to the largest. So that's going to be 50 and 50 percentile. Okay, so this is the role of the median playing for the entire data set, right? So let's say we have 20 members, so the median data set value will be from member 10 and 11, right? If we have 7 members, so the median will be member number 4, correct? It's gonna split up the number of the data set. It's not about the value anymore. So in other words, now we're going to look for Q1. So what is the Q1? The Q1 going to be not a median that going to split up from the smallest up to Q2. So we call this is 25, 25. And this is also 25, 25. Okay, so this is what we have for Q1. The another median that we have here will be the middle data set between the Q2, which is the median of the entire data set up to the largest. So the largest one in this case. So that's going to split up 25 and 25 at the end. So we call this guy as Q3. All right. So what does the Q1 look like? The Q1 is literally, I'm gonna box this and point it out and make it really big so you can see what it is. It's really, really important. So the Q1 will be the median. So we just basically find 3 medians for the entire data set. So the Q1 is the median between smallest and Q2 and up to Q2, right? Up to Q2. I will let you know why it is important. Oh no, there's no equation. There's no math in this. Usually there's no math. I'm not sure why we have the equation for for this kind of topic. There's no equation for this. Okay, for Q3, so that'll be the median between the Q2 up to the biggest, right? Up to the biggest data set value. But there will be some different, and I will let you know why. Okay, up to the biggest. All right. So I want to put them on here, and I will tell you why it is so important up to Q2, and why this is so important to have. And I'm gonna box this with using this guy. Okay, box that. So that's important. So the final number summary, this is what we have here. All right, so this is what the whole definition looks like. So meaning that the 5 number summary basically pick up to 5 numbers. The first 2 number will be the smallest and then the largest data set values. The next number that we have to figure out will be the Q2, so that will be the median of the entire data set. The Q1 and Q3 respectively will be the first quartile and then the third quartile that will split up the data set into 25, 25, 25, 25%.
Can we like do a problem?
We're going to do a lot of problems.
Like, all right.
Maybe 5 problems you want. The reason why we need to do a lot of problems because there will be some exception for that. We need to find a final summary for question number 2, I believe. So I believe this is going to be a very, very important chapter. So that we're going to put in there as, yeah, so final summary. So let's see how it goes. So first of all, we need to arrange the data set. So we know how to compute the mean and standard deviation. Skip that, right? So first of all, we need to arrange the data set in order. If we don't arrange the data set in order, then we're gonna get we're gonna get the wrong answers. Okay, you put them in order, in other words. So the data set that we're going to have, this is the only chapter, this is the only thing that we need to do in order. When you compute the average or when you compute the standard deviation, I can mess them up with the order. This is the example that we have earlier, correct? So, but when we look for the final summary, that we need to put them in order. So the smallest value that we have is 7. And after that, we got 8. And after that, we got 9. And then 9. And then 10. And then 12. And then 15. So there are 7 of them. So that's important. Okay, so what is the middle data set that we can see? The middle data set that we can have in this case?
That's for the mode.
No, not the mode. We ignore the mode. Mode is too much. Mode is just the most repeated. So the median, the Q2 in this case will be equal to 9. Do we agree? Right, so that is the middle data set, right? So we have 7 and 9, and then 10, 12, and 15. Okay, if there are 2 median, what should we do? We're gonna add them up, divide by 2. But if only 1 median, so all we need to do in this case, that we just literally need to point it out So this one is equal to Q2, right? So this is the median we call Q2. Okay. So do you believe that there's only one median? Correct? Right? So there's only one median data set. There's only one median number. So in this case, we're going to queue this. We're going to cross this out. We're going to queue that. Okay. So we can find a median equal to 9. That's it. How can we find a Q1? The Q1 will be from the first data set up to Q2, but we do not count 9 because there's only one median data set for that. Okay, so we ignore 9 in this case. So what is the middle data set between 7, 8, and 9?
8.
All right, so that will be our Q1. So we call this guy as Q1 equal to 8. And what is the middle data set between 10, 12, and 15? What is the middle data set between 10, 12, and 15?
12.
12. So that
12.
that is the Q3. And we're finished. Right? We have the smallest is 7, the biggest is 15.
Wait, that's all you gotta do.
Yeah, this is all you gotta do.
So wait, like you see what we did earlier, right? While we was doing the data, the mean, the deviation, all
Yeah,
that we did.
yeah, the deviation is the hardest part.
All right, but we do this after the STD and all that, right?
Yeah, we do this. And sometimes, remember, if the questions ask us to do the first quartile and the third quartile, or maybe I just ask you find the final summary of the data set. Should we do the mean and standard deviation? No, right? We only do the mean and standard deviation if the questions ask us to do so, right? If the
For
questions ask us to do so. Does it make sense? So if the questions only ask us to do the first quartile and then the third quartile, and then we just do that.
like for example, on this question, it
Yeah.
says and standard deviation. So we do it or no?
If the question asks us to do the standard deviation, the answer yes, we have to do that. But if the question doesn't ask us to do so, then we just leave the final answers as this: Q1, Q2, and Q3. Are we good? So usually I do not combine with the final summary and the standard deviation unless the question worth around 20 points. Because during this final summary, we're going to be getting around maybe 8 points. Would you be able to get 8 points from this question? Right? So let's do another example and see what's going on. There's a lot of exceptions, and let's try it out with question number 4. So the question number 4 asks us to do the mean and standard deviations and the final summary. So we did the first part A and part B, right? So now we're going to do part C, find the final summary of this data set, right? And I'm just going to copy this and put it right there. So let's check this out and see. All right, so now I want you to look for the final summary only, meaning that I'm only due for this part. How many data set that we have? We have 6 of them, right? So n equal to 6. We're now going to do we did the first part A and part B before. So if we have 6 data set, the first step that we have to do will be arranging in order, right? Put them in order. In other words, so we have like a bunch of data set. We have like so to put them in order, we have 8, we have 9, and we have 11, and we have 12, and we have 15.
So it always got to be the least to greatest.
Yeah, from the smallest to the greatest. You cannot be from the greatest to the smallest. So we have to be from the least to the greatest values that we have. So this will be the smallest, and this will be the biggest. So we got 2 numbers. Now, what is the middle data set that we have right here?
You would have to add 11 plus 12 divided by 2.
That's correct. Since we have 2 middle data set, so there's no any one of them, right? So if there are two middle data set because we have two of them. Then we're going to add them up and divide it by 2. So we call this as Q2. Have to be Q2 first. We're going to take 11 plus 12 over 2
Wait, I didn't really understand that.
because we have two middle numbers. How can you determine the median, which is the middle number of the data set? So you have to take the average of two values, correct? So should we pick 11? We cannot pick 11 because if you pick 11, so that'll be biased because this is 11 is not a middle data set. What about 12? Can we pick 12? The answer is no because it's not even the middle data set. It doesn't batten out. It doesn't batten out between 8, 9, 11, 15, 17. So 12 cannot be considered as the middle data set. So what should we do? We just take two middle data, we add them up, and then we divide it by 2. We take the average for two middle data set. So the answer for that will be equal to what? So we take 11, and then we plus 12. We got the answers, which is 23, right? We have to hit equal first. Out of that, you're going to get 17. Okay, you divide it by 2. We divide it by 2. We got the answer, which is 11.5. Right? So for even data set, so n equals to 6, so this 6 is even, we're going to, in order to find a Q2, then you're going to pick two middle number, we add them up and divide it by 2. This is the only math that we do when we have two median only.
And how you know when you have 2 million, so when you only have one?
So depending on whether it is odd or even data set. So in this case, we have 7. So n equal to 7, I guarantee you that this is have to be an odd data set. You can count them 1, 2, 3, 4, 5, 6, 7, right? So when you have an odd, the median have to be the middle data set. When you have an even data, then of course there are two middle data set. We need to add up two middle numbers and then we divide it by 2. Finally, the most important thing is that we're going to split up the data set into 2. Since the Q, we cannot get rid of it. There's no way that we can get rid of 2 middle data set, right? We can only get rid of 1 if there's only 1 middle data set. If we have 2 of them, 1 will go for Q1 and 1 will go for Q2 when we evaluate the Q1 and Q3 respectively. 1 will go for Q1 and 1 will go for Q3. Okay, so in other words, we're going to box these 3 and figure out the Q1. So what is the Q1 in this case?
Is
9.
9. Right, so because 9 is a middle data set, so there are 3 of them, so the median have to be Q1 is equal to 9. And what is the Q3? What is the median for between these 3 numbers?
15.
15?
That's it. I believe I feel like I'm doing too much for today. So when we come back on Wednesday, we're gonna have a little review when we're going to do this example. Let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 different numbers, so the median usually there will be 2 median for that. And then we add them up, divide by 2. But you have to put them in order first. We're gonna do the rest of the chapter later on. Okay. So I feel like that's gonna be it. I call it a day. But again, I just remind you, please submit classwork 2 on Blackboard. Again, that we have to click on assessment. And then we click on the header for the homework so that you can submit it. And how can we submit? Let's say we want to submit homework 3. We click on homework 3. And then, you have to submit it by using browse my computer and then pick the file that we submit and make sure that don't forget to click to hit
I
the
have a question.
Yeah.
Can I like do the homework like on paper and just take a picture and
Yes,
upload it to
please
Blackboard?
just do it on paper. Just do it on paper. That's the fattest way. We can't write the homework on a certain note. That's gonna be really, really complicated. Okay, just do the homework on paper
All right.
and just take a picture for that. If you can convert it to the PDF file, that would be great.
Oh, another question.
Yeah.
Can I mean, when you upload a picture from your phone to Blackboard, it automatically like converts it into a PDF. So
No,
I
you
guess
have to use a certain app. The app that I suggest people using I would say this is the ad. Okay. So remember our class is here. I feel like this is the most important information of class right here. And oh yeah, I have a travel for the tenants. I will let you know. And so you can use certain app, Adobe Scan and Genius Scan are free. So you can use one of this, download it. It's convert automatically to the PDF. So once I read your file, it's gonna be extremely easy, very smooth. All right. So
I use the
please,
Microsoft Lens.
Microsoft Lens also very helpful as well.
I just took a picture and uploaded it. Did you see it? One of the cements. I just took the picture and sent it through Blackboard. I didn't put it in
Um,
PDF or anything.
just go to office hours from at around 3:30, and then I can check your file later on. It's okay. Just go to the Zoom.
Okay.
Yeah.
I did the same thing, but converted it into JPEG. I'm not sure if you saw it because I haven't received a grade for it.
Right. So you're gonna go to the office hour. So one by one, I don't want people to just see someone work on Blackboard. So I will check it out, and so I will show you if I got your file, if I do not got your file. Okay.
So
So
go on office hours on
yeah.
Zoom.
So the easiest way that we can go to the office hour is go to link for office hour in Zoom. So I posted last Tuesday of September.
Question:
1st.
so you can't just take the picture and straight just upload it?
Yeah, you can do that too. I feel like that's going to be the fattest way of doing it.
Yeah, but you say you have to convert it into this.
I mean, it's optional. It's somewhat easy for me to grade, and then usually you're going to get your grades soon.
So let me get this. If I just take a picture from my phone and upload it straight like that.
That would be great. I mean, I have no trouble with that, unless if I cannot read them in terms of like let's say there are certain file I cannot read, just such a MOV, HEIC I can read now. I think on Blackboard, but MOV, the file that I cannot read,
JPG is good though, right?
it's perfect. It's work perfectly
All right. Thank you, Professor.
on my computer. Okay, so I feel like some people were late for class, so it needs to take attendance, and let you guys go. And again, that if you want to check your file, go to the Zoom for today. It's easy. So Shayla is here. Just type.
Excuse me, Professor.
Okay.
Excuse me.
Okay. Banners. All right. So Banners going once. I got you here. Commander. Okay. So absent. Belgium. Wiener. Fantastic. Just say here or yes, present, type, whatever it is. If you don't say, I have to go through your participant. If you have no more questions after you finish your attendance, you can leave the class, you can leave Zoom, and we'll see you guys back on Wednesday. Yeah, I got you. Banners is here. Okay, and we have Ulysses.
Here.
I got you, sir. Afri. Fantastic. And Diego. I saw Diego iPhone, so I just put present. Homework 3 due next Monday. Yeah. Jose. Let me just look through your names so you don't see them. Jose is here. It's not here. And Adamer.
Yeah.
Fantastic. And yes, Belly. Yes, Belly's. Okay. Eric. Okay. So Eric's not here. Arlene. Arlene is here. I saw your Nick. Emily.
Here.
Fantastic. Okay. Katrina.
Here.
Very good. Udor.
Lopez. Okay, I got you. Okay, that person also asked me to put present and year. Yeah, she's here. Barry is here. And Ricardo. I got,
Here.
I got you, sir. And Jones, Otis.
Here.
Fantastic, sir. Kimberly, sir. Kimberly's here. Fantastic. And Janik is also here, but his phone is not working so well. I know that. Okay. Steven's here. Steven. Okay. So, and Selena is here.
I'm here.
Yeah, I got you. Jason's here.
Can you hear me?
Yeah, I got you. Jason's here. Okay. Roberto's here. Roberto.
Yeah, I'm here.
Fantastic, sir. Amber. Amber's here. Is here. Yeah, I got you, sir. Molina's here.
I'm here.
Very good. And Jordali's. Okay, got you. Brian's also here, correct? Brian's is here. All right. So you guys are going to have a great weekend. Oliver's also here. And yeah.
Yes, this is Oliver. I'm right here.
Yeah.
Can you go to the office hours soon or later?
I think after I end the class, I will be on the office hour right now.
On my way over there right now.
Okay. So be there and let me know what it is. You guys are going to have a great day. Take care.